Namaste GATE aspirants, welcome to the GATE Your YouTube channel. In today's lecture, we will discuss the problems on equilibrium forces and free body diagrams. Let us just summarize all the theory aspects before we go into the problems. See, what we have seen is projection of forces. If a force is acting at an angle theta with respect to x-axis, then x component of that force is f cos theta, y component of that force is f sin theta. The next thing is parallelogram law. In the parallelogram law, P and Q forces are acting at an angle theta and the resultant is acting at an angle alpha with the horizontal force. In that case, we obtain resultant R is equal to root of P square plus Q square plus 2PQ cos theta. Theta is the angle between the two forces which are acting initially. The third one is triangle law. When two forces are acting as the two sides of a triangle in the same direction, the resultant is the third one which is acting in the opposite direction and closing the triangle. Next one is sine rule. In PQR are three forces with angles alpha, beta, gamma in between them. So using sine rule, we can write it as P by sine gamma is equal to Q by sine alpha is equal to R by sine beta. Next one is Lami's theorem. In Lami's theorem, when three forces are in equilibrium, as shown in the figure, if they are PQR with angles alpha, beta, gamma in between them, then we can write using Lami's theorem, we can write as P by sine beta is equal to Q by sine gamma is equal to R by sine alpha. The final thing is Reynolds theorem. In the Reynolds theorem, the sum of all the moments due to the individual forces is equal to moment due to the resultant force about the same point. So P into PO plus Q into QO is equal to R into RO. Using this theorem, we can find the resultant and the section at which resultant is cutting. If there are something missing, we will see whenever we get it into our mind, and in between the problems, if any concept is found, we will summarize that also in the same page. Better you write it all the formulas together so that you can revise it whenever you need to revise the subject very fast. Let us see the first problem. Find the resultant of the force system given below. So the figure has three forces acting on it. On the top, an 80 Newton force towards x-axis. In the below there is 120 Newton at an angle, and on the left side there is a 100 Newton force that is also acting at an angle. How to find the resultant now? To find the resultant, as we know the conditions of static equilibrium, we need to apply the conditions, or initially we need to sum up all the forces in the directions of x and y axis using projection of forces. I forgot telling about the static and dynamic equilibrium in the summary. So let us note it down again. In static equilibrium, all the forces should be zero, because if there is any force, that will lead to the acceleration of the body. So then the body is in dynamic condition, so we cannot apply static conditions. If the body is in static condition, the sum of all the forces should be zero. So if we take in x direction, sigma fx is equal to 0, y direction sigma fy is equal to 0, and in z direction sigma fz is equal to 0. The body is in dynamic condition, sigma f is equal to ma, according to the Newton's second law. Now let's go back to the problem. Using projection of forces, sigma fx is equal to 80. Since 80 is acting in the positive x-axis direction, we take it directly, and 100 is acting along the negative x-axis direction. So 100's projection should be taken. The projection is 100 cos theta. So 100 cos 60 minus 120 cos 30. So if we calculate all the forces, we get minus 73.92 Newton. So in the x direction, the force is in the negative x-axis direction. Let us see along the vertical. As 80 is only in the horizontal direction, we will have the projections of 100 and 120 newtons only. So 100 sin 60 minus 120 sin 30, which leads to 50 root 3 minus 60. So 26.6 newtons. That means the vertical force is in the positive y-axis direction. So how we find the resultant between two forces? Using parallelogram law or the triangle law. Now let us find it using the parallelogram law, because it is the easiest way. So r is equal to root of p square plus q square plus 2pq cos theta. Theta is the angle between two forces. Here what is theta? Sigma fx and sigma fy are exactly in x and y directions. So the theta should be 90. So cos 90 is equal to 0. Therefore the resultant is p square plus q square. That is 78.56 newtons. Hence in this problem we use method of projections and parallelogram law. Let us see different problems on different theorems. Let us extend the problem to find the angle of the resultant with the x-axis. So find the angle at which the resultant is inclined. Now we have a force in the x direction minus 73.92 and q, that is sigma fy is equal to 26.6 newtons. So now P is acting in the negative x-axis direction and Q is acting in the positive y-axis direction. How we find the resultant's angle? By using triangle law. Now let us use the triangle law. Let me draw the figure. See, P is in negative x-axis direction, Q is in positive y-axis direction. They should be aligned in the same order, not as in the above diagram. That's why I drew the diagram again. So now they are in the same order. So there should be a resultant which is acting in the opposite direction, closing the triangle. So let us know. we want to find the angle between R and 26.6 or minus 73.92, we can use the sine or cos theta, as we know the magnitude of R. Now let us use tan, because 26.6 and 73.92 are readily available. We use tan alpha is equal to 26.6 by minus 73.92. That gives tan alpha is equal to minus 0.3598. That leads to alpha is equal to tan inverse of the obtained value. M plus alpha is equal to minus 19.79 degrees. So let us denote the minus 17.9 degrees, 79 degrees in the graph. So 0 is positive x-axis direction. If we want minus 19.79, we need to go below it. So let us draw it. So this one is Q is acting in vertical y direction, positive y direction. P is acting in negative x-axis direction. Then R will be acting in the direction which is shown in the figure, that is at minus 19.79 degrees. Hope you all understood the problem. If there are any doubts, please comment in the comment section. Next, we'll shift to third problem. See the figure. Block A is placed on an inclined smooth frictionless surface at an angle 45 degrees, and the weight of the block is 1500 newtons. There is a force which is applied on the block to avoid slipping down. Now what the problem says is determine the value of P. Here in the problem it is specified this: the plane is smooth. That means it does not offer any friction. We have to assume this condition whenever it is given that the surface is smooth or frictionless. So let us draw the free body diagram of the block. If we draw the free body diagram of the block, weight will be acting vertically downward because weight is because of the gravity. So gravity will always act along the direction of the earth, as we are all on earth. So weight should be always vertically downwards, whatever the direction the object may be. And there is a normal reaction which will act normal to the surface of contact of block and the surface. If we take the free body diagram of the surface, the normal reaction will act normally towards the surface. But as we took the block's free body diagram, the normal reaction is acting towards the block and normal to the surface of contact of the block on the smooth surface. As P is the pulling force given, it is acting in the given direction. So now we need to find P. As there are three forces in equilibrium, to avoid the slipping of the block, we need to apply the minimum force is that it should balance the horizontal component of the weight. So let us take the x-axis along the P and y-axis along N. or here as there are three forces in equilibrium, we can take directly Lami's theorem. So N by sin 135 is equal to P by sin 135 is equal to W by sin 90. We can apply that and we can obtain W sin theta is equal to P. Using Lami's theorem also we can solve the problem, but I have taken the static equilibrium conditions, and therefore along x-axis there should be zero force. So W, horizontal component of W is W sin theta is equal to P, and vertical component is W cos theta, hence they both should balance, and 1500 into 1 by root 2 is equal to 1060.6. Hence P is evaluated. Let us see one more problem so that we have a proper understanding on the concepts which are taught in the theory lectures. So here are three forces which are acting in the given directions: TAB, TAC and 600 newtons. So the angle between TAB and TAC is 90 degrees. They have given a angle of 60 degrees between the horizontal line and TAB. Previous gate problem. So let us solve the problem in 1 minute. Solve along with me. So find TAB and TAC. I'll give a hint. This problem can be solved with Lami's theorem. So all you have to do is to find the angles between them. This is a very simple problem. You can solve it within 40 seconds. Pause the video and solve it. I'll try to solve the problem. Hence you pause the video and check the solutions at the end of the video. TAB by sine of the angle between TAC and 600 newtons is equal to TAC by sine of 150 degrees is equal to 600 by sine 90 degrees. So TAB is equal to 600 into sine 120. TAC is equal to 600 into sine 150. Just put the values in the calculator and get 519.6 newtons and 300 newtons for TAB and TAC. That's it for today, aspirants. So thank you. If you have any doubts, comment in the comment section. Thank you, and click on that bell icon so that you will get notified whenever I upload a video.